This is an article about newly added elements to the periodic table. It's official. Chemistry's highest gatekeepers have accepted the newly proposed names for elements 113, 115, 117, and 118. Please welcome to the periodic table Nionium, Moscovium, Tennessine, and Agonicin. Scientists first synthesized the new elements between 2002 and 2010, but it wasn't until December of 2015 that the International Union of Pure and Applied Chemistry officially recognized the discoveries. Then, in June of this year, meaning June of 2016, the scientists who discovered the super heavy, highly reactive elements sent IUPAC their suggested names. After a 5-month waiting period when members of the public could ask questions about the new elements, the foursome were approved in December of 2016, formally filling their boxes in chemistry's most fundamental table. Their names are proposed by the research teams, accepted by the IUPAC. Here are the 4 elements and where their names come from. Japanese researchers proposed nionium, symbol NH, for element 113 from the Japanese word Nihon, which means Japan. A team consisting of scientists from Russia and the United States named elements 115, symbol MC, after Moscow, and element 117, symbol TS, after Tennessee, honoring its pioneering research in chemistry. Element 118 was named Agonicin, symbol OG, for Yuri Agonisyan, a prolific element hunter, by the Russian team that discovered it. This is only the second time a new element has been named for a living scientist. Wait, I thought elements were the basic core of all stuff. What do you mean, synthesized? Let's back up a bit with a middle school science class refresher. The most basic unit of matter is an atom, with its 3 main parts, the positively charged proton, the non-charged neutron, and the negatively charged electron. The protons and neutrons hang out in the nucleus, and atoms are defined by how many protons are in the nucleus. That's where the element's number comes from, called the atomic number. Of the 118 known elements, 94 have been found naturally on Earth. The other 24 do not occur naturally and instead have been made in a lab, synthesized, through a process that involves adding protons onto the nuclei until the total proton count is one that's never been reached before. Scientists think there could be as many as 170 to 210 elements, depending on how many protons they can add to the nuclei. How does one going about adding protons to a nucleus? All the elements left to be discovered, as well as the elements discovered in recent decades, are super heavy elements that are also very radioactive. Making these involves smashing smaller elements together using a particle accelerator. But even when they are created, these atoms are so radioactive that they're extremely unstable, sometimes lasting only a fraction of a second. Almost as soon as they form, they disappear. I see. So do the new elements actually matter for anything? What are we going to do with them? Just create them and let them disappear? For these newest elements, yes. But there are things called islands of stabilities. Despite the general trend of elements getting less stable as they increase in size, there's an occasional element with a magic number of protons and neutrons that makes it far more stable than it should be relative to its size. Experts believe the next island of stability is likely to occur somewhere between elements 120 and 126. But that's just an estimate. It could be element 127 or 171. It even could have been 118, but it wasn't. Once we reach that next island of stability, we'll have a super stable element which may last anywhere from minutes to millions of years, compared with the microsecond lifespan of its neighbors. This could have several industrial applications. For example, it could be a stronger generator of nuclear power. Although we now know there's not much practical use for the newly discovered elements, we can think of them as stepping stones towards an element that could have practical uses. If these were discovered more than a decade ago, what took so long for them to get added? Science is all about reproducibility. Once one team of scientists says it's discovered a new element or committed any revolutionary act of science, other scientists have to confirm the discovery by repeating the experiment and seeing if they get the same results. If other scientists can't confirm the results by reproducing them, people would just go around lying about what their research found. Like, say, this new element they just discovered. To date, aganesium is the heaviest known element, and it doesn't react or bond easily with other elements. It's also on the far right of the periodic table, in a column of noble gases, like neon and argon, which are notoriously inert, rarely reacting with anything. For very complicated reasons, though, Dubna researchers theorize that aganesium is actually a solid, which would make it the first known noble solid, a solid version of a noble gas. It's hard to be sure, though, since only 3, maybe 4 atoms of aganesium have ever been observed. So what happens next? Well, if you look closely, you'll see we have filled up the last row of the periodic table. That means when the next element is discovered, we'll have to redesign the table slightly.